Hello, everyone. My name is Maritza Mills, and I'm a Senior Product Manager with the Route 53 team. And today I'm going to be walking you through how to simplify DNS for hybrid cloud using our new feature, Route 53 Resolver. It's kind of a brief overview of what we're going to be discussing during this webinar. The first is just an introduction, kind of what is Route 53 Resolver at a high level. Then I'm going to give those of you in the audience who might not be as familiar a brief overview of DNS. And then we're going to dive deeper and talk about the challenges of DNS in hybrid clouds, and then specifically how Route 53 Resolver works and how it solves these challenges. And then after that, we will do a console demo so I can show you how this is set up, and then we'll take questions. So at a high level, what is Route 53 Resolver? So this is a feature that we launched at reInvent 2018. And at a high level, it is a managed DNS resolver service that is offered by Route 53. What we allow you to do is create conditional forwarding rules to redirect query traffic between your on-premise data center and your AWS virtual private cloud. And what it does is it allows you to use DNS over AWS Direct Connect or managed VPN. So kind of a brief overview before we get too deep for those of you who need a review. What is DNS? So at a very simplistic level, DNS is the way that names such as www.example.com are translated from those letters into machine-readable numbers. So when two web servers communicate with each other, they use something called an Internet Protocol address. And so I've simplistically labeled when they're at 1.2.3.4. And so what will happen is when you do something like www.example.com in your web browser, it's actually being translated to a number that the client or the server can actually understand. Getting a little bit deeper here to understand how it works, you, the user, might be at your computer and you might type, I want to visit www.example.com into your web browser. And so what your computer or your client is going to do is it's going to reach out to what is called a DNS resolver. And what the resolver does is it doesn't actually know what that translation is. It doesn't know the number that belongs to example.com, but it does know how to find it. So what a DNS resolver does, and this resolver in particular could be something that's provided, say, by your internet service provider. In the case of Amazon Web Services, all your EC2 instances come by default with a DNS resolver. And what it will do is go out and ask different name servers, is what they're called, if they know about the name www.example.com. So the first thing a DNS resolver will do is go and ask what's called root name servers, which are just, I have all of the root names. And when it asks for www.example.com, the root name server, for example, might say, well, I don't know about that full name, but I do know where a .com server is, so here's the address for that. The DNS resolver will take that address and then go ask the name server, okay, .com, do you have the full name www.example.com? And so this will repeat. The com server will say, no, I don't have that full name, but I do know where example.com is located. So it'll give that answer back to the resolver. And the resolver will search again at example.com and ask, do you have the full name www.example.com? And in this case, example.com might be the authoritative server. And we'll say, yes, I do know the answer to that. Here is the IP address, or it's called the A record, 1.2.3.4. Give this back to your client. And so the DNS resolver will take that number and give it back to your client, and that's how you'll connect to the website, www.example.com. So what we're going to talk about today is the challenges of DNS, and specifically that DNS resolution or the resolver piece in hybrid cloud environments between AWS and your on-premises data center. So for example, today, most of you have very simplistically maybe a VPC that is in Amazon Web Services, and you might have a Route 53 private hosted zone there, and then you might have a data center that is on premises. So what happens is when, let's say, for example, your data center wants to talk to a VPC, it is not able to do so. The resolver that exists in your data center is not able to recurse out to any kind of name servers that exist for your Amazon VPC. And likewise in reverse, if your VPC was trying to find a name that existed on-prem, it would not be able to perform that resolution. It would not be able to find that name. So what a lot of customers have done is they have decided to set up their own custom DNS servers. So they do away with the EC2 default provided DNS resolver, and they might set up their own, either maybe an open source software or some kind of proprietary software that they've set up. And what they will do is what's called conditional forwarding. So in this case, the on-prem data center won't just ask for a name. It will have some kind of logic that says, when you see a name like example.com, I already know that it's at this IP address. Here's the server that knows how to find it. And it will forward it directly to, for example, the server that exists in your VPC. And this is something that customers have set up as a workaround. And so in this case, this is how many of you are getting bidirectional query resolution today, is doing that back and forth forwarding. One of the problems with this is that it's causing many customers to have to turn on the default provided resolver service that exists in their VPC. And so you're having to manage and install your own servers when you could have been using a default service that you didn't have to think about. So kind of a more complex scenario. Most customers that we've seen may actually have multiple VPCs with multiple different accounts. And so it's a very similar situation. The server cannot actually connect to any kind of authoritative name server that is in Route 53. And so what customers will do, again, is put a custom DNS resolver inside of their VPC. In some cases, depending on whether or not a customer needs to resolve names that are specific or local to that VPC, they might have to put a resolver in every single individual VPC or in every single account at a minimum. And then for those of you who want much higher availability, you might have a resolver sitting in every single AZ just for redundancy. So let's talk about how Route 53 resolver works and how it helps replace those workarounds and simplifies this whole experience. So essentially what happens is you create an endpoint, and that endpoint sits on your VPC or is attached to your VPC, and those endpoints have an IP address. Similar to what we talked about before, your data center will have some logic that says, if I want www.example.com, I know that my server doesn't know the name, so forward it to the location that does know the name. So in this case, you would use the IP address of the endpoint that sits on the VPC. And we'll go over a little bit of how you assign that IP address to the endpoint, but just know for now that it does have one that you can forward to. And so what this will do is when you send that query to the endpoint will then redirect the traffic to the Amazon provided DNS server, and will continue the resolution that way. In reverse, if a VPC wants to query something that is on-premise, you will have the ability to create what's called conditional forwarding rules. And those rules look identical to something that you might do on-prem. You'll say, if I have something like on-prem.example.com, I know that the server that has that name is at this IP address, so you'll forward it to some DNS resolver that is on premises, and you'll be able to resolve the name that way. So digging in a little bit deeper, so to the left you have your data center, and to kind of show where the traffic is going through, you will have a VPC, and Route 53 Resolver is a regional service. So for those of you who are new to this, you may typically think of Route 53 as a completely global service, and that is true for authoritative DNS. But when it comes to the resolution piece that's actually looking for the names, it is regional to your VPC. So you will put an endpoint on a VPC within a given region, in this case US West 1, and you will then, when you create that endpoint, be asked to spread that endpoint across, at a minimum, 2 different availability zones, just as a best practice for higher availability. And you will choose an IP address that comes from that VPC's own subnet space. And that IP address is stable, and it can be used consistently from your on-premises data center as a forwarding target. So what happens is when your network says, I want to forward this query for this name, example.com, to this IP address, it will go to the endpoint's IP address. The endpoint will then say, okay, let me go and forward this to the resolver, which will do the lookup for you. And then that resolver will do the lookup as we described earlier in the presentation, and it will send the answer back over, whether it's Direct Connect or Managed VPN, to your on-premises DNS resolver and provide the answer there. So going in the reverse direction, let's say that your VPC needs to actually get an answer that is on-prem, so something like onprem.example.com. What will happen is that a VPC, maybe over here to the right, will have a query such as onprem.example.com. It will have rules attached to it. In this case, we've got jyo.example.com. And it will say, okay, I'm querying jyo.example.com. I know that this is actually stored at a different address. So the resolution will say, I found a match. Let me forward this back out over the endpoint that we talked about. So you have one VPC on the right that is attached to a rule. It will forward that query out through the VPC that has the endpoint attached. So that's something to keep in mind, is that you only need the endpoint in one VPC. That's kind of the gateway in and out of, let's say, your AWS network. But the rules can be attached to multiple other VPCs that don't necessarily have an endpoint. And what they will do is forward their queries out through the VPC that is hosting the endpoint, and then that VPC, that endpoint, will actually forward the query back out over Direct Connect or VPN to your on-premises data center. So how does it work more specifically when we talk about rules and what the rules are doing? So what a rule says is that if you have something like www.example.com, forward it to some IP address that you designate. And so rules can be very specific. You can have this www.example.com, you can have a.example.com, you can have a.p.example.com, you could go all the way and be as specific as you want. Something to keep in mind, though, is that in general, the rules are matching domains based on wildcards. So if you have a rule that is just example.com, then any of those previous names that I mentioned, a.example.com or b.example.com, essentially any subdomain off of example.com will match queries for that rule and forward them to that location. However, if you want to do the wildcard matching, but you may have a more specific name that should be forwarded in a different direction, we have designed it so that the most specific rule wins. So in this case, if you have a rule that is just example.com, then, for example, queries such as a.example.com or b.example.com might match to that rule. But if you also have a more specific one for the subdomain www.example.com, it will only match to that rule because that is the most specific name. So that's something to keep in mind when you're setting up the rules, is that the most specific DNS name wins. So more specifically, how does it work with sharing rules? So one of the benefits of moving to Route 53 Resolver is that customers can use Resource Access Manager, and this is commonly referred to as RAM, to share forwarding rules across multiple accounts. So what will happen is that you might have the endpoint that is in account 1, and it has a set of rules that are attached to that endpoint. But then you will also be able to share those rules to other VPCs. So those rules in, say, account 3 will forward queries through account 1, through the endpoint in account 1 based on those shared rules. Rule sharing is regional, so you can only share rules with other accounts as long as all of those accounts are in the same region. Keeping in mind that only rules are what's shared, not endpoints directly. So the process is a VPC has an endpoint, and the endpoint has rules, and those rules are shared with other VPCs. You're never directly sharing the endpoint itself. You're sharing the rules, and the rules are attached to an endpoint. And so this way, one outbound endpoint can actually serve multiple VPCs. So it's not necessary for you to put an endpoint in every single VPC. And just going back to the illustration from earlier to kind of drive this home, if you see on the right, there are 2 different VPCs. They are not actually hosting the outbound endpoint. the outbound endpoint is actually being hosted on a different VPC, which you'll see to your left, which is connected back to on-prem directly. And so instead, these VPCs on the right are associated with one or more rules. You can see the top right VPC is actually associated with both the JYO rule and the RIC rule, whereas the VPC on the bottom is only associated with the RIC rule. Regardless, because both those rules are associated with the outbound endpoint on the VPC to the left, if there's a match on one of those rules that apply to those VPCs on the right, it will be forwarded out through the endpoint that is attached on the left back through to on-prem. So specifically, again, how does it work with VPC-specific answers? So for some customers, they may want to get an answer from on-prem that is, say, maybe an EFS name or another type of service that is local to the VPC. So what happens in this case, let's say on-prem you want to resolve some kind of an EFS name. If you have VPC peering turned on, so in this case the endpoint is in account 1, and account 1 is peered with a VPC in account 2, where the EFS name is located, that resolution will work because the peering is there. In the case of no VPC peering, if you want to resolve a name that is specific to the VPC from on-prem, you would have to put an endpoint in the individual accounts. Because those names are specific to the VPC, just forwarding to the VPC in account 1, it's not going to be able to find names that are specific to VPCs in account 2 and 3 without peering. And so another bit of how does it work is limits. So we see this question a lot from customers. As far as the endpoint is concerned, it has a limit of about 10,000 queries per second through each ENI. So a endpoint that has a single Elastic Network interface can accept 10,000 queries at one time. So you can up that limit by provisioning more than one ENI and attaching it to your VPC. Something to keep in mind as far as limits go is that a VPC's local resolver, remember I said earlier each EC2 instance has a resolver available by default provided by the Amazon DNS server. You don't pay for that particular service. What it does is that VPC resolver has a different limit. It's closer to 1,024 packets per second. And so what will happen is that if you do have rules that apply to a particular VPC, the Amazon DNS service is going to say, you know, is there a rule that applies to this particular query? So example.com. If the answer is yes, then those queries are going to be routed back through the endpoint. And so the limit applies there. That's when that traffic starts going through the endpoint. If the answer is no, that query actually stays local to the VPC. And so that query never sees your endpoint and it won't put any kind of load on your endpoint. So now we're going to go to a console demo to kind of show you how it works. So here I am in the Route 53 console, specifically on the Resolver console. You can find it over to the left-hand side of your navigation. Something to keep in mind, again, is that Route 53 Resolver is a regional service. So unlike the rest of Route 53, you'll be able to choose different regions like you do with other regional services such as EC2. And so keep that in mind when you're making the change between, say, setting up an authoritative hosted zone or registering a domain, which is more global in nature. When you move to Route 53 Resolver, you will be assigned to the last region that you were in. So it's important that you check in the upper right-hand corner to make sure that you're working in the region that you want to work in. And so what I want to do today is I actually want to configure an outbound endpoint, meaning that I want to be able to forward traffic that is inside of my Amazon VPC and send it back out to a resolver that exists in my on-premises data center. So I'm going to start by clicking Configure Endpoints. Okay, and just as a reminder, again, it's letting me know that I am signed in to US East 1. If US East 1 is not the region that I would want to work in, I would just come up to the top right-hand corner and make sure to change that. So in this case, when you start with the wizard, it's going to ask you, do you want traffic to go in and out of the VPC? Do you only want it coming into the VPC? Or would you like for it to go outbound only? So for the purpose of this demo, I'm only trying to send traffic out over an endpoint back to an on-premises data center. So I'm going to click the one on the far right. So the first thing it's going to ask me to do is give the endpoint a name. It can be any name that you want. And then the next thing is it's going to ask you to pick a VPC that is located in the region that you are in. So I have the one VPC that I'm going to select. And so this endpoint is going to be specifically attached to this VPC. And then it's going to ask for a security group that can control the access to this VPC. I'm just going to use the default in this case, but you do have the option to create more. And so here's where the assignment of the IP address comes in. So for this particular outbound endpoint, I'll be able to choose an IP address based on the subnet of the VPC that I've chosen. So in this case, I'm actually going to start out by choosing an availability zone. And then once I choose the availability zone, I'll be able to choose the subnet space that I want to use. And below, when I'm selecting an IP address, I can opt either to have the system automatically choose an IP address for me, in which case it'll just pull something that is free from your existing subnet space, or I do have the option to create my own just for whatever purpose I would like to have one specifically set by me. For the purpose of the demo, I'm just going to have it create it automatically for me. And so again, as a best practice to make sure that I have a highly available service, I'm going to choose a different availability zone inside that VPC. And then I'll choose the subnet space for that. And again, I'll just have it automatically create the IP address. And then if I want, I can actually add more IP addresses. So this is really up to how much load you think that you're going to need to handle as far as queries per second, as well as how highly available would you like it to be. 2 is what is recommended as a best practice, but if you would like to go at higher and higher levels of availability, that's certainly an option. And so to reiterate what's happening here when you create an IP address, the IP addresses themselves are what are mapped one-to-one with an ENI. So earlier when we talked about the ENI that was attached to the VPC, each IP address that you create is creating a single elastic network interface and attaching it to your VPC. So at this time, I have 2 different ENIs that are in 2 different availability zones. If I were to create a third one, I would then have a third ENI. And then optionally at the bottom, if I wanted to tag the endpoint to make it easier to find or for another reason, I do have that option below. Okay, so I've created my endpoint. And so now, since this is an outbound endpoint, I'm going to be asked to automatically create at least one rule for that endpoint. So in this case, I might want to create like an example.com rule, which would just say anytime this name exists, I want you to forward it here. So I might call it example.com. One thing that we've seen common with some enterprise customers is that they might actually want to say, by default, why don't we just forward all of our names back on-prem, and then we'll make an exception for certain names that we know exist inside of AWS. And customers do this for different reasons. I just wanted to emphasize the wildcard factor of what is happening. So in this case, why don't we create a forward all rule? So I'm actually going to backspace this and call it forward all. And so what this will do is actually say every query that comes through our VPC, go ahead and forward it. And later what I can do is I can create more specific names and say that I would like, okay, forward everything except example.com, send that back to Amazon VPC and resolve that locally. So the next thing I'll do after naming it, for now, just forward all, I'll choose a rule type. And so I'll either choose a forward rule, which is what I'm going to be doing in this case, or a system rule. The system rule is what I described as letting you send it back to the Amazon provided DNS server. The forward rule is what I want to use if I'm trying to send it outside of AWS. So in this case, I'm going to choose the forward rule. And now I'm going to specify the domain that I would like for it to forward. So in this case, since I want to forward everything, I'm going to go with kind of the wildcard approach, and I'm just going to use the root or a single dot. And so what will happen is any DNS name that comes across will be forwarded based on this rule. And if I want to prevent that from happening, I can either remove this rule or I can create more specific rules that point to other IP addresses. And as a start, when I'm here, I can choose one or more VPCs. Right now, I only have one, but I can go ahead and apply the rule that I've created above to other VPCs. So not just the one that has the endpoint, but maybe other VPCs that are inside of the same account. Okay, and this is just reminding me that I am using my webinar endpoint in order to send these rules out. And so the final part of configuring it is just selecting the IP address for where I want it to go, and just for the purpose of this demo, we'll simplify it. You enter the IP address that you would like for that domain to forward to from here. And you can actually have multiple forwarding targets. I'm just going to have one, but if there are multiple addresses that you wanted to forward it to, you could. And even for rules, we also have the ability to tag rules so that you can group them together. Okay, so moving on. Once I've created my endpoints and I've created my rules, it's just going to give me a quick summary screen to make sure that I've got everything done the way I wanted it to. And I am satisfied with this, so I'm going to go ahead and click Submit. And so what it's doing right now is it's actually creating and attaching the endpoints. This could take a few minutes. So I want to walk you through a previous one that I created to kind of show how you might navigate around and understand what's happening. So in this case, I'm in the VPC screen, and I have my one VPC, and I can already see at a glance that there are two rules associated with this VPC, as well as two outbound endpoints that I've created. At this time, there are no inbound endpoints. So I'm just going to click on this VPC for more information. So when I click on the VPC, at the top, it's going to show me two different rules that have been created. These right now are at the top an auto-defined rule that is created by the system. You'll see these. These are not for anything that you would have to worry about. Here's the forward all rule that I just created, and you can see that it's still being created right now. Below here are the two outbound endpoints. This is one that I actually created earlier. This is the one that we created just now as part of the demo. And the status is still creating, so it hasn't actually attached yet. And then as you can see, there's actually no inbound endpoints. So if I want to find out more information about either a rule or about a particular endpoint, I can do that. I'm going to click here to get more information. So on my outbound endpoint right now, that's just called my outbound endpoint, I can see that the status is operational. I have the ID and the name, as well as the security group attached to it. And then I can see the IP addresses that were auto-assigned to this endpoint and whether or not they're currently attached. And so remember, an IP address is the same as an elastic network interface. And so what I'd like to do next is actually go and look at the rules that I currently have assigned to this VPC. So here are all the rules that I have assigned. Again, this one is a auto-defined rule that's created by the system when you create an endpoint. This rule is the one that I created earlier called forward all. So I can click on this rule to get more details. So I have the name. It looks like it has completed. The sharing status to the right is how I can share this with other VPCs that are not in the account. So when we were going through the wizard, I could add this rule to multiple VPCs, but only if they existed inside of the same account. What you can do once you've created the rule and once the endpoint has attached is then you can go back and attach those rules to VPCs outside of your account using Resource Access Manager. So to do that, I would follow the share button here. And this will actually take me to a different console, which is the Resource Access Manager console. And so I'm going to stop here. And I just want to thank you for coming and listening to the webinar today.